Alright, we are given this situation. It says, in the school year ending in 1993, 2 million females participated in high school sports. By 2003, the number had increased to 2.86 million. We need to write a linear model for the situation using 1990 as t equals 0, and then we want to find out how many students there will be in 2012. I'm using that model to predict. Okay, the first things we look at here is we've got a bunch of dates and amount of people, but we don't have a slope, we don't have a specific y-intercept. It wants us to write a linear model. That's an equation. So the things we do know is we know that in 1993 there were 2 million female students. In 2003 there were 2.86 million. Now, we don't need to switch these and add all the zeros to the millions. We just know that our y values are in millions. However, when we come down here, it says using 1990 as t equals 0. What that's doing is that's setting 1990, the year 1990, as our year 0. That's our starting point for years. So that way you're not plugging in, or if you go to graph this at some point, you're not plugging in 1,993. So it's saying 1990 is year 0. So since 1990 is year 0, then 1993 would be year 3, because that's 3 years past 1990. So this point is actually going to be the point 32. 1993, 2 million people. 2003, well, if 1990 was year 0, 2003 would be 13 years later. So that's year 13, and there we have 2.86 million. So those are going to be the coordinate points that we're going to use. We created coordinate points. We've got year, comma, number of female athletes in millions. So now we want to write our equation. We have 2 points, so we learned previously that we're going to need to find the slope. So if we have our x1, y1, and x2, y2, we're going to plug them in. So our slope will be 2.86 minus 2, my y2 minus y1, over 13 minus 3, my x2 minus x1. That'll give me 0.86 over 10, which if we divide that out, we get 0.086 will be my slope. Okay, we also want to write the equation, so that's my slope, that's my rate of change, average rate of change. It has a bunch of different names. We're going to plug into our slope-intercept form, our point slope, so y minus y1. Again, it doesn't matter what points you use. I'm going to be using the 0.32 because those numbers are much happier. So y minus 2, we do the y value first, equals 0.086 x minus 3, because that's my x1 value. So we're going to solve for y. So we've got y minus 2 equals 0.086 x minus, and then we need to do 3 times 0.086, which is 0.258. We're going to add 2. So we get y equals 0.086. So we're going to have 2 minus 0.258, which will be plus 1.742. Okay, so this is telling me, oops, I forgot my x. My year, or y is standing for the number of female athletes, so the number of athletes I'll have will be 0.086x, which is my t, so if we wanted to write this as a t, we could, because we're looking at our t value, plus 1.742, keeping in mind this is years and millions of female athletes. Okay, then it wants to know how many will there be in 2012. I'm going to go ahead and change this y to a, so we know that that stands for athletes. So when we plug this in, it makes a little bit more sense. Okay, we want to know in year 2012. Well, if you think about 2012 in terms of our 1990 year, so in 1990 was our year 0, so that means 2012 will have been 22 years later. So we're looking at 22 years later, so 22 is going to be my t value. So we're going to have a equals 0.086. We're going to do 22 years, so we'll plug in 22 for t, plus 1.742. So if we type that in. Here you'd want to use a calculator, so we'd have 0.086 times 22 plus 17. Whoops, just kidding. So let me try that again. We got 0.086 times 22 plus 1.742, which gives us A to equal 3.634. Now, this is not an appropriate way to leave your answer because this problem is dealing with a real-world situation, so you always want to relate your answer back to the problem. So we know that A is standing for the number of female athletes, so we're going to say there will be, in 2012, there will be 3.634 million female